So in level 3s, we're not going to solve by graphing, we're going to solve by another way called substitution. So what we're going to do here is we are going to solve for one variable, okay, even if it has expressions in it, and then replace it for the others. So if we're looking for A, I'm looking at A here, I see that y equals 5. So if I told you that y equals 5, and I asked you to find out what x was, you may have the intuition to plug it in for the y right there. So instead of 2x plus 3y equals 5, you're going to replace the y, oops, not y, there you go, 2x plus 3, and instead of y, I'm going to replace it with negative 5 equals 5. So now I'm going to solve this. So I got 2x minus 15 equals 5. Add the 15 to the other side. And x is going to equal 10. So just like you had in level 2 and level 1, you had a coordinate point for your answer. So your answer is going to be whatever you got for x, comma, whatever you got for y. It's still a point in which where these two lines intersect, you just found it in a different way. Alright, let's take a look at this one now. So with this one, I don't have just a y equals a number, but I do have y equals an expression. And now sometimes it'll be x equals, and you can substitute in for that. It's not always substituting it in for x. So what we're going to do is we're going to plug this in for that. So instead of y, I'm going to write negative 4x plus 8 minus 2x equals negative 10. So I plug that into the top equation there. So I'm going to combine like terms, negative 2x and negative 4x is negative 6x. Okay, so I got x equal 3. Now, the next thing that you have to do, it's different than the last one because I actually have to find out what y is. Since you know what x is 3, you can either plug that into equation number 1 or equation number 2, whatever is easier. I look at this and I think equation number 2 is easier because y is already solved for or kind of by itself. So I'm going to use equation number 2, y equals negative 4x plus 8, and I'm going to substitute what I found x to be. So I got y equals negative 4 plus 3 plus 8. So y is going to equal negative 4. So your final answer then is 3, negative 4. All right. Number 6 works the same way, it's just got C's and D's in it. So again, what you could do is you could solve for either one of the variables. You can solve for C and plug in that expression, or you can solve for D and plug in that expression, since not one is solved for yet. So if I'm looking at the top one, I typically want to leave that alone because it has two coefficients in front of the variables. In the second equation, I look at 2C and 1D. And I think it's easier to solve for the D because it doesn't have a coefficient on the front. So it's just one step less than if I was to solve for C. But if this was the other way around, you could definitely solve for C. Okay, so now that I have D by itself, I'm going to replace what D equals into D into the other equation. So I'm going to have 5c minus 3 times negative 2c plus 7 equals 23. So to solve this, I'm going to go ahead and distribute. So this is 11c. And C looks like to equal 4. So again, since I got C to equal 4, I can plug that into either equation 1 or equation 2, or even equation 3, the one that you rewrote, to figure out what D equals. Again, since I don't know, I'll plug in an equation 2 this time. So I've got 2c plus d equals 7. So I got 2 times 4 plus d equals 7. 8 plus d equals 7. If I subtract 8 from 7, I get -1. So then my answer is 4, -1. Okay, cruising right along here. We got 2 special cases. So we came across one graphing yesterday, and that was when it was 2 parallel lines. Remember, that's a no solution. Well, when you have, when you're solving by substitution, it's going to look a little bit different. Let's take a look how that works out algebraically. So with this one, I got this. I'm going to plug that into y. 2x plus -2x plus 5 equals 5. Now 2x and -2x, that equals 0x plus 5 equals 5. 0x is technically just 0, so I'm left with 5 equals 5. Now that's a true statement. 5 does equal 5. It's the same number. Okay, this is one of those cases where on a graph, you would be graphing the same exact line. You'd have 2 equations that were the same exact line. And this is what we call infinitely many solutions. Now the next special case, over here looks like this. So you've got, plug this in for y, 2x plus -2x plus 3 equals 5. So again, the same things happen. 2x and -2x come out to be 0. They cancel out. So you're left with 3 equals 5. Now, over in the first one, I said 5 equals 5 is a solution, or a true statement. But 3 equals 5 is not, because 3, obviously, is not the same thing as 5. So this is where we have no solution. And on a graph, this is where we would have 2 parallel lines going in the same direction, but never intersecting. Okay?